The rare earth elements, also called the rare earth metals or rare earth oxides, or the lanthanides, are a set of 17 nearly indistinguishable lustrous silvery white soft heavy metals. Scandium and yttrium are considered rare earth elements because they tend to occur in the same ore deposits as the lanthanides and exhibit similar chemical properties, but have different electronic and magnetic properties. The 1985 International Union of Pure and Applied Chemistry Red Book recommends that lanthanoid is used rather than lanthanide. The ending -ide normally indicates a negative ion. However, owing to wide current usage, lanthanide is still allowed and is roughly analogous to rare earth element. In pure form, these metals tarnish slowly in air at room temperature, and react slowly with cold water to form hydroxides, liberating hydrogen. They react with steam to form oxides, and at elevated temperature ignite spontaneously and burn with a fierce colorful pyrotechnic flame. These elements and their compounds have no known biological function. The water-soluble compounds are mildly to moderately toxic, but the insoluble ones are not. The rare earths have diverse applications in electrical and electronic components, lasers, glass, magnetic materials, and industrial processes, but since they do not occur as base metals or in lump or visible quantities like iron or aluminum, their names and properties are unfamiliar in everyday life. One of the most familiar may be unusually powerful neodymium magnets sold as novelties. Despite their name, rare earth elements are relatively plentiful in Earth's crust, with cerium being the 25th most abundant element at 68 parts per million, more abundant than copper. All isotopes of promethium are radioactive, and it does not occur naturally in the Earth's crust. However, a trace amount is generated by decay of uranium-238. They are often found in minerals with thorium, and less commonly uranium, because of their geochemical properties. Rare earth elements are typically dispersed and not often found concentrated in rare earth minerals. Consequently, economically exploitable ore deposits are sparse. The first rare earth mineral discovered was guadolinite, a black mineral composed of cerium, yttrium, iron, silicon, and other elements. This mineral was extracted from a mine in the village of Ytterby in Sweden. 4 of the rare earth elements bear names derived from this single location. According to chemistry professor Andrea Seller, rare earth elements differ from other elements, insofar that rare earth metals, when looked at anatomically, seem to be inseparable from each other, in that they are all almost exactly the same in terms of their chemical properties. However, in terms of their electronic properties, their magnetic properties, each one is really exquisitely unique, and so it can occupy a tiny niche in our technology, where virtually nothing else can. For example, the rare earth elements praseodymium and neodymium can both be embedded inside glass and they completely cut out the glare from the flame when one is doing glass blowing. A table listing the 17 rare earth elements, their atomic number and symbol, the etymology of their names, and their main uses is provided here. Some of the rare earth elements are named after the scientists who discovered them, or elucidated their elemental properties, and some after their geographical discovery. A mnemonic for the names of the 6th row elements in order is, lately college parties never produce sexy European girls that drink heavily even though you look. The first rare earth element discovered was the black mineral, ytterbite. It was discovered by Lieutenant Carl Axel Arrhenius in 1787 at a quarry in the village of Ytterby, Sweden. Arrhenius's ytterbite reached Johann Gudelin, a Royal Academy of Turku professor, and his analysis yielded an unknown oxide that he called yttria. Anders Gustav Ekeberg isolated beryllium from the gudelinite but failed to recognize other elements the ore contained. After this discovery in 1794, a mineral from Bastnäs near Ridder Ryttem, Sweden, which was believed to be an iron tungsten mineral, was re-examined by Johannes Jacob Berzelius and Wilhelm Heisinger. In 1803 they obtained a white oxide and called it ceria. Martin Heinrich Klaproth independently discovered the same oxide and called it ocoria. Thus by 1803 there were 2 known rare earth elements, yttrium and cerium. although it took another 30 years for researchers to determine that other elements were contained in the two ores ceria and yttria. In 1839, Carl Gustav Mosander, an assistant of Berzelius, separated ceria by heating the nitrate and dissolving the product in nitric acid. He called the oxide of the soluble salt lanthana. It took him 3 more years to separate the lanthana further into didymium and pure lanthana. Didymium, although not further separable by Mosander's techniques, was in fact still a mixture of oxides. In 1842, Moser,